Now in section 6.2, we are starting to do something which perhaps seems obvious after 6.1. In all the examples in 6.1, we threw something through the air, but we started by throwing it horizontally. Well, what if we don't throw horizontally? What if we start throwing at a different angle? And these questions would look something like this. So the simplest example we can do, apart from throwing something horizontally, the next simplest thing we can do is throw it straight off the ground, right? So imagine, probably the easiest thing to imagine here is kicking a ball from the ground up into the air. So you kick it with an initial velocity, u, at an angle of alpha, okay? Now, we still have the horizontal motion and the vertical motion. The horizontal motion is still s equals vt, and the vertical motion is still governed by u, v, a, s, and t, okay? But this u here is not the same as this initial velocity here. This u here is the speed that we're moving upwards at, okay? Now, what we can do here is do what we've done in the other chapters with forces, but we do this with the velocity. So this velocity is the result of travelling horizontally at a certain speed and vertically at a certain speed. So horizontally, we're going u cos alpha, there's the right angle triangle, there's the hypotenuse, there's the angle, we're adjacent to the angle, so u cos alpha. Vertically, we're going u sine alpha. So the initial vertical velocity is u sine alpha, where this u here is the same as this u here, not as this u here. Now, I'm not going to apologise for using u's in too many places, because this happens a lot of the time in the questions. They say initial velocity u, and then you want to use u for your vertical component of the initial velocity, but in the question they've already used a different u. So you're going to have to come up with a way around that. Maybe one way around it would be just to call this one u dashed or something to separate them. Another way around it would be to relabel this. I'll say I'll have an initial velocity of, I don't want to use an x or a y, so let's have an initial velocity of a z. So this is then z sine alpha. But unfortunately, the confusion is there in a lot of questions, so I'm going to leave it there in my example. So initial velocity is u sine alpha, and then everything else works the same as before. Acceleration is minus 9.8, displacement and time and all the rest of it, okay? Now then, that's really that's it, right? We're going vertically and horizontally. We're going not vertically and horizontally, rather we're going off in a certain direction. We can split that up into a vertical and a horizontal component. Let's have a look at example 4 and see how we apply the information then. So a particle is projected from a point on a horizontal plane. So here is my horizontal plane. It's projected from that with an initial velocity of 40 at an angle alpha. I'm on page 111, by the way, in the book. So 40 meters per second in that direction and an angle alpha. And this angle, what do we know about it? Well, tan alpha equals 3/4. Find the horizontal and vertical components in the initial velocity. And that actually, in this exercise, that's all we're going to be asked to do. In section 6.3, we'll have the next examples where we are asked to find more things. But vertical and horizontal components, well, the horizontal component is 40 cos alpha. The vertical component is 40 sine alpha. So horizontally, vertically. Now, we could find cos alpha and sine alpha by just doing tan inverse of 3/4 and working from there. But if you remember this, when tan is 3/4, there's alpha opposite over adjacent are in the ratio 3/4. So by Pythagoras' theorem, that must be 5. So cos is 4, so 40 times 4/5. And vertically, we get 40 times 3/5. So 40 divided by 5 is 8. 8 times 4 is 32. 40 divided by 5 is 8. 8 times 3 is 24. And the next thing it asks us to do is express the initial velocity as a vector in terms of I and j. So in other words, it's going 32 horizontally and 24 vertically. It's going to the right and up, so these are both positive. So there's my vector, which is the same as 32i plus 24j. Now, unless I'm mistaken, I think actually oh, there we go. There's 7 questions in the exercise. The first 4 of them ask you exactly the same question over and over. find the horizontal and vertical components, and then write them as a vector. It's not always handy to write them as a vector. Sometimes it is, sometimes it isn't. By the time we get to the last chapter, I think chapter 8 of the book, then we deal with these vectors an awful lot. But that really is the idea in exercise 6b. I'll do the more complicated examples in section 6.3, but there's not actually any new maths in the next section, it's just applying these ideas.